This video is about understanding and using Newton's second law of motion, F equals ma. So let's go through some theory first. So Newton's second law of motion, what does it say? It says if there is a resultant force acting on an object, then that object will accelerate in proportion to the magnitude of the force. Okay, in other words, the resultant force acting on an object in a certain direction is equal to the mass of the object multiplied by the acceleration in the same direction. So this is the formula that you need to remember. The resultant force in a certain direction is equal to mass times acceleration in the same direction. This all assumes mass is constant, e.g. modeling a rocket using these laws would be invalid. Okay, the only other thing that you need to know is weight is equal to mass times g, where g is equal to 9.8, remember in this syllabus, meters per second squared. So weight is equal to mass times g. Okay, let's go through some questions. So a car accelerates along the horizontal road. The car's engine generates a driving force of 12,000 newtons. Find the frictional force between the tyres and the road if the 1500 kg car accelerates at 6 meters per second squared. So we've got a car on a road. The driving force is 1200 newtons, so going forward is 12,000 newtons. Acceleration, so it's traveling this way, is equal to 6 meters per second squared. Friction is acting in the opposite direction to the driving force, so friction here. Vertically, we have the reaction force from the ground and the weight of the car pulling it down, which is equal to mass times g, so 1500 g. Okay, what we're trying to find is the frictional force between the tyres and the road if the 1500 kg accelerates at 6 meters per second. So resultant force to the right is equal to mass times acceleration to the right. So Newton's second law applied horizontally gives us the resultant force, because it's moving in the right, it must be equal to 12,000 take away friction, which is acting in the opposite direction, which must be equal to mass, which is equal to 1500 times acceleration, which is 6. Which means 12,000 take away friction must be equal to 9,000. So friction must be equal to 12,000 take away 9,000. Friction must be equal to 3,000 newtons. A block of mass 6 kg falls through a gloopy liquid which provides a resistance force of 18 newtons. Calculate the acceleration of the block. So you've got a block. Weight is equal to 6 times m times g, so 6g. Resistance force of 18 newtons, so it's pushing it up. It's falling through, so down, so acceleration must be equal to a. So remember, F is equal to mass times acceleration for Newton's second law. So Newton's second law applied vertically must be, because it's moving down, the resultant force must be 6g, which is moving down. The force is acting down, take away force is acting up. So 6g take away 18 is equal to mass, which is 6 times acceleration. So acceleration, if I rearrange it, will be 6g minus 18 over 6. Don't forget g is just 9.8. Take away 18 over 6, which gives me a value of 6.8 meters per second squared. A block of mass 5 kg falls through a gloopy liquid with an acceleration of 3.2 meters per second squared. Calculate the resistance force provided by the liquid. So we've got a block of mass 5 kg, so that means weight will be 5g. We don't know the resistance, so let's just call it R, resistance. You can call it just resistance because you want to confuse it with the reaction force. It doesn't have a reaction force because it's not touching anything. And we know that it's accelerating down with the acceleration of 3.2 meters per second. So F is equal to mass times accelerations, Newton's second law going vertically. So it's moving down. So that means 5g minus resistance, which is R, must be equal to mass, which is 5 times acceleration, which is 3.2. So resistance will be 5 times 3.2. No, sorry, that's not how you rearrange it. It will be 5g take away 5 times 3.2. So resistance will be, if you put that into your calculator, remember 5g is 5 times 9.8. For the time being, I'm just going to write in. Later on, I won't write 9.8. I'm just going to assume g is 9.8. You understand that. So 33 newtons. Therefore, resistance force is equal to 33 newtons. Okay, next question. You have to find the missing values. So here, let's do one here. So F is equal to mass times acceleration, which means 15 is equal to mass, because it's traveling mass, which is 5 times acceleration, which means acceleration is 15 divided by 5, which is 3 meters per second squared. For this one, F is equal to, again, mass times acceleration. It's traveling to the right, so F must be equal to 2 times 3, which means F is equal to 6 newtons, because it's a force. Okay, again, F is equal to mass times acceleration. It's accelerating to the right, so that means 17 take away 8 must be equal to mass, which is 6 times A. So that means 9 is equal to 6A. So A is equal to 9 divided by 6, which is 1.5 meters per second squared. Okay, it's accelerating to the left, so that means the resultant force will be equal to 17 take away 11 mass times 2. So that means 6 is equal to 2m, which means m is equal to 6 divided by 2, which is 3 kg. Okay, it's accelerating to the right, so that means resultant force is equal to mass times acceleration. So resultant force will be F take away 22 is equal to mass, which is 4 times acceleration, which is minus 4. So F is equal to minus 16 plus 22, which means F is equal to 6 newtons. Okay, again, F is equal to mass times acceleration. It's moving to the left, so that means 23 take away 29 must be equal to mass times minus 2.5, which means minus 6 is equal to mass times minus 2.5. So mass must be equal to minus 6 divided by minus 2.5, which is equal to 2.5 kg. A force of 10 Newton acts upon a particle of mass 3 kg, causing it to accelerate at 2 meters per second along a rough horizontal plane. Calculate the value of the force due to friction. So we've got a particle, we have a rough surface. So I normally draw a rough surface just slightly curved. If it's straight, if it's a frictionless surface, so if it's a smooth surface, I draw a straight line. So the particle has mass 3 kg, so that means the weight will be 3g. Obviously, there's a reaction force involved. Okay, we have a force of 10 newtons acts upon. So let's say if it's traveling this way, then 10 this way. And we also have, because it's a rough horizontal surface, we'll have friction actually acting in the opposite direction. It's accelerating at 2 meters per second. Calculate the value of the force due to friction. Okay, so again, if we have Newton's second law going horizontally, F is equal to mass times acceleration, then resultant force is 10 take away friction, because 10 is going the same direction as the resultant force, as the way it's traveling. Friction is acting in the opposite direction, times mass, which is 3, times acceleration, which is 6. So 3 times 2, which is 6. So friction must be equal to 10 take away 6, which means friction is equal to 4 newtons. A lift of mass 500 kg is lowered or raised by means of a metal cable attached to its top. The lift contains passengers whose total mass is 300 kg. The lift starts from rest and accelerates at a constant rate, reaching a speed of 3 meters per second after moving a distance of 5 meters. Find A, the acceleration of the lift. So we have to set up a SUVAT equation. So we know it's traveled a distance of 5 meters. It started from rest, so initial is 0. It got to a final velocity of 3 meters per second. We're trying to find acceleration. We don't know the time. So we've got S, U, V, and A, which means V squared is equal to U squared plus 2AS, which means 3 squared is equal to 0 squared plus 2 times A times 5, which means A will be equal to 3 squared divided by 2 times 5, which is just 9 divided by 10, which is equal to 0.9. So acceleration is equal to 0.9 meters per second squared. B, the tension in the cable of the lift is moving vertically downwards. So we've got this. Okay, so what we do know is the lift is accelerating downwards. So that means acceleration is going down and it's 0.9. The lift feels a weight of it has got a mass of 500 kg, so it'll be 500 g from the lift, but also the passengers add a weight of 300 g as well. Okay, and the lift also feels tension pulling it up. So that means Newton's second law applied vertically means, so F is equal to mass times acceleration. It's moving downwards, which means 500 g. So forces acting down is 500 g plus 300 g minus tension must be equal to mass, which is 500 plus 300 times acceleration, which is 0.9. Which means 800 g minus t is equal to 800 times 0.9, which is equal to 720. T must be equal to 800 g minus 720, which works out to be 7,120 newtons. The tension in the cable if the lift is moving vertically upwards. So for part C, it's a different diagram we're going to draw. So now it's still feeling 500 g plus 300 g. Tension moving, going up. Okay, acceleration is accelerating up now by 0.9. So now if I do Newton's second law, vertically F is equal to m times a, then because it's moving up, it'll be T take away 500 g take away 300 g will be equal to total mass, which is equal to 500 plus 300 times acceleration, which is 0.9, which means T minus 800 g must be equal to 720, which means T must be equal to 800 g plus 720, which must be equal to 8,560 newtons. Okay, the reason why I didn't include the reaction force from the man on the lift is because the reaction force are equal and opposite, so they will cancel out. Okay, a trolley of mass 50 kg is pulled from rest in a straight line along a horizontal path by means of a horizontal rope attached to its front end. The trolley accelerates at a constant rate, and after 2 seconds, its speed is 1 meters per second. As it moves, the trolley experiences a resistance to motion of magnitude 20 newtons. Find the acceleration of the trolley. So we need to do a SUVAT first to work out the acceleration. So we don't know the distance traveled. It starts from rest, so it's 0 meters per second. Final velocity is 1. Acceleration is what we're trying to find out. Time is 2 seconds. It takes 2 seconds for that journey. So we've got VU VAT, so that means V is equal to U plus AT, which means 1 is equal to 0 plus A times 2. So A will be equal to 1 divided by 2, which means A is equal to 0.5 meters per second squared. Okay, so part B, tension in the rope. So I need to draw a force diagram. So we've got a trolley. We have, its mass is 50 kg, so the weight is 50 g. We've got a reaction force because it's on a horizontal path. It's on obviously, it's got contact with the ground. It's got a driving force. So, sorry, it's being pulled by horizontal rope, which means there's tension on this rope. And what we do know is there's a resistance to motion of magnitude 20 newtons. So 20 newtons going this way. And we know it's accelerating at 0.5 meters per second. So if I do Newton's second law going horizontally, then F is equal to mass times acceleration. Resultant force is going to be T, because it's moving in the direction of T. T minus 20 is equal to mass, which is 50 times 0.5. So T is equal to 25. 50 times 0.5 is 25 plus 20, which means T is equal to 45 newtons. The engine of a van of mass 400 kg cuts out when it's moving along a straight horizontal road with speeds 16 meters per second. The van comes to rest without the brakes being applied. In a model of a situation, it is assumed that the van is subject to a resistance force which has a constant magnitude of 200 newtons. Find how long it takes the van to stop. So the first thing I need to do is work out acceleration. So we've got a engine of a mass. Mass is 400 kg, so it's pulling 400 g down. We've got reaction force pulling up. When it's moving along a straight horizontal with speed 16 meters per second, the van comes to a rest without the brakes being applied. So that means there is a resistance, remember, of force of 200. So that means it's accelerating in the opposite direction. So Newton's second law horizontally, so F is equal to mass times acceleration, is moving forward, so in the to the direction of to the right. So that means the resultant force is actually minus 200 because the 200 is acting in the opposite direction. Mass times acceleration, which means acceleration is equal to minus 200 over 400, which means acceleration is equal to negative 0.5 meters per second squared. But that's not what we're trying to find out. It says find out how long it takes for the van to stop. So that means we have to use SUVAT. So after we've done this, we're applying SUVAT. So we don't know the distances traveled. We know the initial speed is 16. Because we want it to come to a stop, the final velocity will be 0. Acceleration is minus 0.5. We just worked it out. Time is what we're trying to work out. So UVAT. So V is equal to U plus AT, which means 0 is equal to 16 plus minus 0.5 times T. So T will be equal to negative 16 divided by negative 0.5. So T will be equal to 32 seconds. B, how far the van travels before it stops. So we're just trying to find S now because we know what T is. So we can use any formula, so any equation of motion formula. So S is equal to U plus V over 2 times T. So S is equal to 16 plus 0 over 2 times T, which is 32, which is equal to 256 meters in the calculator. So this is part B, using the information that we already have. Okay, C, comment on the suitability of the modeling assumption. Okay, the resistance force is unlikely to be a constant magnitude as air resistance will increase with speed. So if you think about it, as an object speeds along, the air resistance that it experiences also increases. So that's why it's unlikely to be constant. So resistance unlikely to be of constant magnitude as air resistance increases as speed increases. Okay, next question. A car of mass 750 kg is driving along at a constant velocity against a frictional resistance of 900 newtons. Suddenly, the car hits an icy patch so that the frictional resistance are reduced instantly to 0. Calculate the acceleration of the car. So we've got two scenarios here. So the first thing is before he hits the icy patch and after he hits the icy patch. So before hitting icy patch, because that will tell us what the driving force is. Before car hits icy patch, if I draw the diagram, then we've got the car has weight 750 G. Reaction force here. We've got a driving force that we don't know, so let's just call it driving force. And we have a frictional force, which is 900 newtons. It's traveling at constant velocity, which means acceleration is 0. So Newton's second law applied horizontally, F is equal to mass times acceleration. So that means driving force take away 900 must be equal to mass, which is 750 times 0, because acceleration is 0, which means driving force take away 900 is equal to 0. So the driving force is equal to 900 newtons. So that's equal to 900 newtons. Okay, so now after car hits icy patch, what we do know is that the frictional resistance is obviously reduced to 0, so there's nothing acting left now. We still have the driving force, which is 900 newtons. We've got the reaction force, and we've got the weight, which is 750 G. And now we're trying to work out acceleration. Newton's second law, so it's accelerating forward. Horizontally, F is equal to mass times acceleration. So the resultant force is just 900 in the positive direction, so just 900. Mass is 750 times acceleration. So acceleration will be 900 divided by 750, which means acceleration is now 1.2 meters per second squared. So by eliminating the frictional resistance, the acceleration has gone from 0 to 1.2. A bucket has mass 5 kg when empty and 15 kg when full of water. The empty bucket is lowered into a well at a constant acceleration of 5 meters per second by means of a rope. When full of water, the bucket is raised at a constant velocity of 2 meters per second. Find the tension in the rope when lowering the empty bucket. So when you're lowering the empty bucket, so the bucket weighs 5 kg, so 5 g is the weight. Feels the tension pulling it up. And we know it travels down with a constant acceleration of 5. So Newton's second law applied vertically. F is equal to mass times acceleration. The resultant force will be 5g take away t. Mass will be 5 times 5. 5 times acceleration, so 5 times 5. So tension will be equal to 5g take away 25 when rearranged. So T will be equal to 24 newtons. B, when raising the empty bucket. So we've got the bucket now, but now it's feeling tension, obviously. Now when it's full, it says it's 15. When raising the empty. I think it's supposed to say when raising the full bucket. So full bucket will be 15g, weigh 15g. And it's moving up. But the velocity, it has a constant velocity of 2 meters per second. Now, constant velocity of 2 meters per second means acceleration is equal to 0. So Newton's second law applied vertically. F is equal to mass times acceleration. So it will be T minus 15g is equal to mass, which is 15 times acceleration, which is 0. So T will be equal to 15g. So T will be equal to 147 newtons. The last thing I need to go through is the modeling assumptions that you need to memorize for obviously the exam. So the key ones that you need to know is light. So when we talk about a light string, so light, when you're talking about a light string, you talk about tension being the same. The assumption that we made is the tension is the same at both ends of a light string. Okay. In an inextensible string, acceleration is the same in objects connected by a taut inextensible strings. So how I remember is inextensible has 5 syllables, acceleration has 5 syllables. So when you think about inextensible string, think acceleration is the same. Okay, a smooth surface, no friction between the surface and the other object on it. A rough surface, obviously, objects in contact with surface experience a frictional force. So there's a frictional force involved with it. So when it's a smooth surface, I normally draw it straight. When it's a rough surface, I sort of draw it a bit curved, so a bit wavy. Okay, the other one that I would say you should know is small light pulley, smooth and light pulley. So pulley smooth, light pulley has no mass, but smooth means tension is the same on either side. So this one is light, this one is smooth. Okay, the other one I would say is air resistance is negligible, obviously, in this course, and gravity, which I always talk about, is 9.8 unless otherwise stated. Okay, so please take a look at this before an exam to make sure you know the modeling assumptions that are made in the mechanics applied paper.